Alright, apologies for the delay. I'll be finishing off C3 today, but I'll be doing a video for each separate topic because it gets a little bit more complicated here. So let's get straight into it. Percentage yield and atom economy. Between the two, percentage yield is quite easy. So the formula for percentage yield is your actual yield. And when we talk about yield, we're always looking at what you get in the end, so your products. Okay? So your actual yield divided by your predicted yield, what you think you're going to get, and you times it by 100 because it's a percentage. Both of these will be given in the question. And it's fairly straightforward. Now, when you're making any sort of chemical, you're not always going to get 100% yield, or you're not going to get all the product that you want out of the reaction. And reasons for the reason that you're going to get less than 100% percentage yield is because it's going to be lost. It's going to be lost through filtering. It can be lost through evaporation, or just any simple process in which not all of your starting product, or not all of your reactants, that's also your starting product, okay, reactants and starting product are the same thing, not all of your reactants will become your end product or your products. Fairly straightforward. In any large-scale industries, they don't want anything that produces low yield. You always want high percentage yield. And the reason they want high percentage yield, so that way it lowers the cost, doesn't cost as much to make it, and that way you're not wasting your reactants, less waste of your reactants. You don't want to be wasting reactants if you're not going to be getting the product. So that's percentage yield. Very straightforward. The numbers will be given to you in the question. And that's all I can say. It will say actual yield, predicted yield, so that's very easy. Okay? So percentage yield, always looking at the end product. Most of the time it will be less than 100%, and it's lost because of filtering, evaporation. Not all of your reactants become products. And in large-scale industries, you want high percentage yield, so that way it doesn't cost as much, and that way you're not wasting your reactants. And the equation is actual divided by predicted times 100. I believe this is one of the ones that will not be on your equation sheet, so you do need to make sure that you memorize that one. So that's percentage yield. Okay, I'm going to rub this out and do atom economy, which is going to take a little bit longer to explain, but again, still fairly straightforward. When you're looking at atom economy, again, you're also looking at the products. So with the atom economy, you're looking at how many atoms have been wasted when you're trying to make your whatever chemical, when making your chemical. Now, the equation for this, you're looking at the relative formula mass of what you want, of your desired product, so that's what you want. And you're dividing this by the relative formula mass of all products. So that's everything. So I'm going to do two examples of this, and hopefully that should be enough. And I'll do the second one will be a little bit more complicated than the first. Okay? So for the first problem, let's say the equation or the question tells you calculate the atom economy for making hydrogen by reacting zinc with hydrochloric acid. Now, the question doesn't tell you straightforward, this is my desired product, these are all the products. you have to interpret it. It's almost like a maths problem. Normally they'll give you the equation. So it says, calculate the atom economy for making hydrogen. So what we want, the desired product is hydrogen. Okay? And it says there you need to react zinc and hydrochloric acid. So the formula when you combine zinc, oh, that's getting faint. Yeah, let's check it. Zinc, I'm sorry, zinc and hydrochloric acid gives you zinc chloride and hydrogen. Remember, when we're looking at atom economy, we're only looking at the product, so you can just ignore the reactants. We're looking at everything on the right side of the arrow. Now what we want, the desired is hydrogen, and all the products will be zinc chloride and hydrogen together. So these two together are all the products. But the one that we want is hydrogen. So now we've done relative formula mass. In the previous video, I'm just going to quickly rub this out, and I'll repeat it again what the formula is. Remember, it's desired divided by all the products. So basically, I wonder if I have enough room here, maybe. So hydrogen, H2 tells us we have 2 hydrogens. And if you look up in the periodic table, remember it's always the top number. Hydrogen has a relative formula mass of 1, but because there's 2 of them, it's 2 times 1, which will give us 2. We have ZnCl2, ZnCl2. What does that tell us? You've got 1 Zn, and you've got 2 Cls. So if you look it up, Zn, it's 65 and 30, and chlorine is 35.5 and 17. So you're going to have 1 zinc, so it's going to be the top number, so 65. Chlorine 35.5, and there's 2 of them, so 2 times 35.5. Okay, that gives you 71. So now just plug it into the formula. Desired product, so your desired product is H2, so that's going to be 2, divided by all the products. So all the products, you've got 65 plus 71, that's for zinc chloride, plus you need to add your hydrogen again, so plus 2. Okay, so that gives you 2 divided by 138. Okay, and you have to times it by 100, and that gives you 1.45% atom economy. So let's go through that again. The formula is desired divided by, so what you want divided by all the products. I forgot to add here, and you times it by 100. So what you want divided by all of what you actually get, times it by 100. This question, calculate atom economy for making hydrogen. So I've circled it, that's our desired, that's what we want, by reacting zinc and hydrochloric acid. So zinc and hydrochloric acid, we ignore that because we're only looking at the products for atom economy. Gives you zinc chloride and hydrogen. Zinc chloride and hydrogen, that's all the products together, but what we want out of this reaction is only the hydrogen. So we just go on to calculate the relative formula mass for hydrogen and zinc chloride, just like you had in C3d. So hydrogen, 2 atoms of it, so 2 times 1 gives you 2. Zinc chloride, 1 zinc, 2 chlorines. So you look up zinc and that's 65. Chlorine is 35.5, but because there's 2 of them, you times it by 2. That gives you 71. You're ready to plug it in. Desired is 2, because that's hydrogen. All the products is both of these together. So 65 plus 71 plus 2, you times it by 100, and you get 1.45%. I'm going to stop that there. I'll just do another video for another example for atom economy, and then we'll move on to C3F.